Welcome back to the age detection tutorial second part. In this part I'm going to do the age detection and color separation. Let's do some recap first. Last session, which was the first session of the age detection, I did the image opening technique. So basically for this opening, use the IEblog command and the image name, as long as the image is in same working directory as the program is saved in. So this command will work, and obviously, as I mentioned, that this code I'm showing here is guaranteed to work in Matlab 2019, but the earlier version of Matlab is not guaranteed to work. Now, for converting an image to grayscale, we use the following code: RGB to gray and the image variable. So here you can see the A. So this A is basically this A variable, which has the image has already opened, and the next part is detecting the age. For the age detection, we use this following code, which is the variable name equal age, and defining the variable B. The process name is a pre-wheat. We can write the Sobel, we can write Kenny, depending on which age detection technique we really wanted to implement on. Now the next part we did also for detecting line of code by putting percentage before the line. So basically, if you put a percentage before the line, the code gets deactivated, and you see the color also change, and if you just delete the percent sign, so that make the code active again. Now, for plotting two images in one figure, we use this following line of code. So basically, at the beginning you write the subplot command, then you specify how many rows and column you want to get. For our image, we use that one row and three column image, and the image number here we can see the first one is image number 1 and the second one is image number 2. So in this way you can compare two images side by side, also the number of images as you wish. Now I will proceed to further. Here I have opened the same line of code I just left last time. So we will modify this line of code to color separation of the grayscale image. So here you can see that B equal RGB to gray, which is the grayscale conversion of the color image of hand.png. Now if we just write here, then put some text on just for visualization. Title, color separation. Now go back to the code. For the color separation, at the beginning we need to assign a variable name. So as I have used the name A, B, C, D, let's use the name G here. So we do color separation of B, bracket, so here in this line of code, if I wrote number 3 in the third part of the bracket, so if the 3 indicate the color red, the 3 indicate the color blue. Let's comment it. So if I just show this G, let's copy and paste it. Let's run this section of code. Okay, we see some error. Well, let's not use this line of code. We change this line of code to just a different method. RGB equal I am split unsplit A semicolon semicolon subplot 2 to 1 I'm sure R, which is the red component, give it a title, red channel, bracket, how about running the code now. So we can see that our red channel image is showing in the subplot, but it's just plot number 1. So we will compare 3 color side by side. So let's just copy this line of code, copy subplot 2 to 2, this time is the green G. This G we are finding because we have already assigned in the code here R, G and B. So the first one is the red, green and blue. So I'm sure G, give it a different name, green channel. Now the third one, we copy this line of code, the third one three, B for blue, changing the name, blue channel. So if we just select this line of code and just run the section, this section, run section, here we can see we got these 3 image, red channel, green channel and blue channel, they coming side by side. So let's just analyze. You see this red, green and red channel, green channel and blue channel, each of them has got 255 pixel, but the pixel intensity is different in their each color map. So basically there is 3-dimensional array. When these 3 image overlap, they produce a color image of this image. Let's clear the whole code. from yesterday. If we just run the whole thing, so we got our clean code. Let's just save it as a different file. Save as that tutorial part 2. Okay, now let's combine the 3 color image. So previously we separated 3 color image. Now we will combine them just to show that it can produce the original image. So again, text, title, code. So I give it a different variable name. So in this case I'll say p equal, the command is cat, cat. Cat is for combining. Cat 3 channel, so 3 red, green and blue 3 channel. So the name we have previously assigned here is that red, green, blue RGB. So we write the same thing, just copy from inside. Semicolon. Subplot. Many of the code here I'm just copying and pasting because I want to practice myself. Also I can recommend you to do modular approach in programming. Modular approach in programming is that you write line of code and you can reuse it in number of times. I've been told this is a standard practice in programming. So modify this code. So got 2 row 2 4 I am show p combine channel, title, combine channel, what will happen now? So here you can see this is our combined channel image. We got the red channel, green channel, blue channel and the combined channel. So overlapping these 3 frames can produce this image. Now I will do individual edge detection. So give it a highlight again, text, title, individual color component edge detection, code, if I just write for the red color component, red edge RE equal edge bracket R semicolon comment red edge detection, subplot, this one, copy, paste, changing the name, detection, so if we just run the section of the code, so selecting run section, okay, now copy the whole thingy, then changing the name, this time is green edge, G, green edge, subplot number 2, GE, so which is green edge, title green channel edge detection, let's select all these, run section, yes, it's doing, Control V, this time blue channel edge detection, BE, edge is blue, comment is blue edge detection, subplot number 3, so I am sure BE, title blue channel edge detection. Now one combined channel, this P, which is the combined of all the 3 frames, so I want to do it side by side just for a comparison, so Control V, this time it is P is the combined image, so PE edge, want to do the P edge detection, subplotting number is 4, just check, so 3 4, so PE combined channel, title BINE, combined channel edge detection, just select this line of code, run section, okay, we got an error, okay, so this combined channel, we need to deactivate this line of code, selecting, commenting, now this is deactivated, oh. Okay, it's giving the error, that error using edge, expected input number 1 I to be 2-dimensional. Okay, so this PE image has got 3-dimensional array, which is red, green and blue array, so we want to make it 1-dimensional, which is the grayscale image. So basically this is the same as that B, so we just change the name to P2, changing the variable B, which is our grayscale image, PE combined channel image. Okay, let's play it now, run section. Okay, here we get that 3 color channel image. We can just zoom in, we can see there are some subtle changes. Basically here in this finger we see different pixels, like at the top of the finger we don't see any pixel here on the green color channel, and the blue color channel we can distinguish 1 2 3 4 5. We can distinguish all the fingers. So basically this is the comparison, and you can see different color channel. How about I'm changing the, let's change the image. So we got the hand PNG, we change it to the ski image, ski.png, this image ski.png. so just changing the name and using the same code, ski.png. okay, let's run this code. Okay, now I'm sure A. Okay, so I've got the color image, grayscale image, then combining the all the edges. So here we can see the edge detection of 3 different color component edges, though it is not possible to distinguish between different color component edge detection at this moment, but different pixel intensity can be seen in other picture. Let's see some picture with different contrast. How about the road PNG? Changing the name, road. Okay, so this image, you can see the color image, grayscale image. So red channel edge detection, green channel edge detection. So all of the edge detection are canny edge detection. About this image, RGB.png. yeah, that's it. This is better image. Okay, that's a JPG image. JPG. Okay, so this is the main image. It has got 3 pure color component. One is red, green and blue, that has been converted to the grayscale image. So this image has got 3 dimension, red array, green array and blue array, and this gray image has got only 1 dimension. Here is the color component separation. So basically we've got the pure red. So pure red in red channel, here we see that only pure red is detected and has been put. So here the only pure red channel edge is detected, and here in green color channel image you can see only the green color is detected. So here is the green color, and this color edge is detected here, and blue channel edge detection. So this part is detected, which is blue, this part. How about showing it in one frame? All the color component, different color component. Okay, here we can see there's two different image plane is overlapping each other. So basically, if I can just deactivate this line of code, which is the edge detection code of different color channel, so comment it, that will deactivate it and it will change the color to green. So now only this line of code is activated. If we run the whole code, that give us this picture. So red channel, green channel, blue channel, and combined channel. Now if we just activate this line of code now, uncomment, this will activate this line of code, and running the whole thing here, you will notice that only edge will be detected in this color channel in red component here, and blue edge will be detected here, green channel edge will be detected here, and combined channel edge will be detected here. So if we just run this code now, here we go. So this way we can detect the edge of grayscale image, different color component image, also the combined color component image. The combined color component image edge detection is basically grayscale image edge detection, because with this current line of code we are using, it can't detect edge in the color image. For that there is a different code. Let's talk about some upcoming project in this channel. Currently I am developing a computer vision based robotic guidance system. Here basically, as you can see, this car I will be using. So basically I have generated this card in 3D parts, then I used Raspberry Pi with onboard camera. So basically the camera will see things whatever is in front of it. So the image will come from the camera, it sees things whatever in front of it, then the image is processed, image is segmented image will be post processed before it is sent to the feature extraction part in the code. This code I will be using Python programming language with OpenCV. OpenCV is a open source computer vision algorithm for Python. It also can be used for C, also in Matlab programming language as well. It was developed by Intel. So I'll be using OpenCV to extract the image and recognizing the object, recognizing the obstacles whatever is in front of it. So the robot will be programmed to go towards its target and avoiding these obstacles. Basically I'm designing a robot, a general purpose robot, which can be utilized in pick and place robotics, also search and rescue robotics. I will be publishing this coursework in next 2 weeks, so stay with me.